Hi all, welcome to yet another video in the EKS Anywhere saga series. By now, if you've been following the blogs, you would have realized how easy it is to deploy an EKS Anywhere cluster on top of a vSphere environment. Now, moving on, in this specific video, we would like to now tackle how do we deploy persistent and stateful applications on top of EKS Anywhere clusters running on vSphere. Generally speaking, when you are deploying persistent stateful applications, it's always preferred to have an external storage like a Dell's PowerStore, PowerFlex, or a PowerScale for file and block and things like that. But there could be scenarios where you may prefer the vSphere environment if it has an associated data store, which could be a vSAN, and specifically in a HCI kind of arrangement, a hyperconverged infrastructure, you may wish to utilize the same vSAN data store not only to host the virtual machines for the EKS Anywhere cluster, but also to deploy your persistent applications so that those container volumes, the persistent volumes, appear on the same vSAN data store and they leverage the same capacity. Now, it's as I said, it's a preferred thing to actually have an external storage, but there could be scenarios where you may benefit from a converged system, a hyperconverged system, and you would like to have all your data, the virtual machines and the container volumes also on the same data store. Now, in this blog, we will look to actually deploy persistent volumes for a sample workload, MySQL, let's say, which represents a stateful application, and utilize the vSAN data store associated with my VxRail, which is a jointly engineered platform between Dell and VMware. Now, you could be dealing with any hyperconverged infrastructure. I'm using VxRail here, and we will look to actually bind the container or the persistent applications through a vSphere CSI deployment, which is actually the link between the container's PVC, persistent volume, and a container volume residing on the vSAN data store. You need that vSphere CSI to be deployed. Essentially speaking, prior to version 0.16.0, EKS Anywhere already had a default implementation of the VMware or vSphere CSI, along with a default storage class. So when you actually deploy something like that, it automatically creates, if on the same data store. But after version 0.16.0, the vSphere CSI support has been discontinued, which means it's not been discontinued, but it's not a default implementation. Otherwise, in a prior case, once you create the EKS Anywhere cluster, this was fairly simple. Now we will see how do we actually do this, in the newer versions of EKS Anywhere. And this video is associated with the medium.blog as always. So let's look at the blog. So the blog is already there, EKS Anywhere deploying persistent and stateful workloads with vSphere CSI. Okay. Now, most importantly, if you look at a diagram, this diagram, okay, let's understand what we're talking here. So in my case, I have a physical infrastructure, which is a hyper-converged infrastructure with VxRail, and it is bearing a vSAN data store. Now, when we create the EKS Anywhere cluster, obviously, the cluster will have its virtual machines, the control plane nodes, and the worker nodes. These virtual machines, when created on top of vSphere, those the VMs are backed up by the virtual disks on the data store. But at the same time, when we deploy these stateful pods, for example, a Redis or MySQL or Postgres or whatever, the PVCs via the vSphere CPI CSI will actually be created as container volumes on the same data store. Okay, you can further maneuver, things like putting in storage-based policy management and things like that. But that's an advanced topic. Now, the point here is your VMs for the cluster plus the stateful pods, they all reside on the same vSAN data store. Okay. Now, Luckily, although EKS Anywhere has removed the default implementation of the CSI, the CPI part, which is also an integral part to the whole linking, CPI stands for Container Provider Interface, I so believe. That's also an implementation and a prerequisite to deploying the CSI. Fortunately for EKS Anywhere, that exists, which actually enables the communication, to the vSphere environment actually, and that's important because creation of virtual machines and all those things actually happen through the CPI. Now, the I've already included the significance of this implementation as to prior to 0.16.0 what was the default behavior, and then now where do we stand. Let's move on. What we will do is, starting in this blog, we will create a fresh EKS Anywhere cluster. Okay, so obviously to start with, I need a YAML file. And first, let's look at my vSphere environment. Like I said, I have a VxRail cluster. Okay, it's a 4-node cluster. You can see that it's a 4-host cluster. And it has a data store, which is a VxRail virtual SAN data store. Okay, and you can see that the container volumes are showing nothing. Now, when we create the persistent volumes on the Kubernetes EKS Anywhere cluster, those PVCs will actually start showing up as container volumes as opposed to regular volumes. And you should see this particular table being populated with the volumes that we create. Okay, so how do we begin? Let's look at, this is the folder. And I already have the admin machine created, which is the bootstrapping machine to create the EKS Anywhere cluster. I am already logged into that admin machine. Okay. And I do have the YAML file here, which is my cluster configuration file. I will not go through the entirety of the file. If you want to refer, please refer to the previous blogs, and you should understand what this cluster configuration file means. But I do have the control plane configuration, machine configurations. So this one here, and I do have the worker node machine configuration. Okay, they are both going to be 4 vCPU machines with 8 GB memory actually. Okay, important things actually are on the worker nodes. When they come up, I'm going to apply a label, a node label of group :MD0. Now, this will allow me to target the CSI node drivers, which will also come up as the pods. These are the CSI driver pods, to be only operating on the worker nodes actually, as opposed to the entire cluster, which is control plane and worker nodes. So we will target the worker nodes to be hosting the node drivers. And this could be particularly useful if you have multiple node groups actually of different size of machine configurations, and you want to only have your persistent applications residing or only on a specific set of nodes, right? It could be useful. So we will look at this particular case of deployment. Note that this is the same value of labels which we will put as node selectors in the the CSI driver deployment YAMLs actually. Okay, so that's about it for the cluster YAML. As of now, you can see that there are no virtual machines under this folder. When we start the cluster creation process, you will see machines popping in. This is going to be a 5-node cluster, 3 control plane nodes, which also includes the etcd, and 2 worker nodes actually, which are going to be bearing the applications that we deploy on the cluster. Okay, so let's go ahead saying, let's just follow. So here, so EKS Anywhere create cluster, and the file is going to be this. Now, obviously, to start with, some amount of validation will happen on the cluster configuration file. The connectivity to the vSphere is being validated, and a bootstrap cluster is being created of the cluster kind Tine cluster, which will host the cluster API components and all that. All that has been documented in the previous blogs. And from there on, the actual cluster will come up that will that is represented through the virtual machines resident on the vSphere environment. Okay, so this will take about 10 to 15 minutes. Let me pause the video and resume when this is fully created. Okay, so we can see that the cluster is fully created. And let's look at the virtual machines which are a part of the cluster in the vSphere environment. So we can see that 1, 2, and 3 control plane nodes and 2 worker nodes with MD0 as a part of the node name, right? So this is a 5-node cluster. We've got the virtual machines up. Like I said, these virtual machines are resident on the vSAN data store because the template which is used to create these virtual machines, the data store that has been provided is the same vSAN data store, right? So these VMs obviously are backed up by that data store, but that's just the cluster part, okay? Now we've got the cluster running. Let's just set the kubectl context. So let me export kubeconfig variable /home/ubuntu/ the cluster name directory and the auto-created kubeconfig file. Okay, so now let's access the cluster. Okay, so we can access the cluster. We can see the same machine names here as a part of the cluster. They are running version 1.29 of the EKS distro. Okay, I did mention that I've applied labels. This is going to be a little bit of verbosity. So let's see the labels on the worker nodes. So you can see that group equals MD0 and group equals MD0. These are the 2 worker nodes on which these labels have come up. The control planes don't have this label, okay? Now, the next part would be to deploy the CSI drivers, okay? Now, if we go to the documentation, this is slightly dated documentation, but it neatly describes, what has to be done. But if you go to this documentation, there's a lot of prerequisite actually suggested here, right? And in this case of EKS Anywhere, a lot of these prerequisites have already been met actually, especially the CPI deployment and things like that. So we don't have to worry about those things. And I've documented that in the blog as well. We need to only focus on the CSI deployment, and I'll walk you through that as well. Let's first create a namespace, okay, which is going to be called as VMware System CSI, which will actually host the CSI driver pods and the necessary resources for supporting those drivers. So we'll create this namespace in our cluster. Okay, the namespace is created. Next, we need, now I've already mentioned that, as per the implementation docs, you have to go to the virtual machines and do disk enable UUID so that, you can get a provider ID attached to the VMs and all that. But we don't need to do any of that in the EKS Anywhere. It's all done for us. Those prerequisites need not be, and that's something that I wanted to also make sure that, the audience gets it, because sometimes it can be confusing because, the implementation of vSphere CSI is done from a vanilla Kubernetes perspective, right? So there's a lot of extra steps that ideally in EKS Anywhere we need not follow. So let's validate if our nodes do have the provider ID set, which is there actually, right? So the UUID is already enabled for those virtual machines. Next, we will actually create a secret in the vSphere or the VMware System CSI namespace. This secret will allow the node drivers to communicate with the vSphere to create the necessary volumes and things like that. Now it's going to be a conf file, creation of a conf file, and the content of that conf file is from here to here. vSphere CSI supports both block and file. We are only going to be demonstrating the block volumes as of now in this example. So for creation of the block volumes, this content is more than enough, which includes the cluster ID. Now, this cluster ID is the Kubernetes cluster ID. Every Kubernetes cluster has a UUID when it gets created. How do we get this? We can run this particular command to observe the cluster ID. Okay, so I store it as a variable. So let's just take this EKS cluster ID equals to dollar this command and store that as a variable on our system. Okay, so let's echo the cluster ID to see if indeed we have retrieved the value. Oops. Okay. Sorry. Dollar cluster ID. Okay, so this is the UUID for our EKS Anywhere cluster. This is an important variable that we need in the conf file. Okay, let's take now this particular command, which will insert into a file CSI vSphere.conf. The quoted value is already there with it, dollar EKSA cluster ID. So we would see that the value will get automatically inserted in this particular file here, right? I will have to stop recording and stop sharing for me to actually insert the password. Let me do that. Let me just first create this file. Okay. And for now, I will stop sharing and just edit my CSI vSphere conf file and insert the right password. Okay, I could have done that with a variable as well. My bad, but let me do it statically. Okay, done. Let me reshare my screen. Okay, so this file is created with all the right variables. And you need to also include the data center, which is going to be your top order object here. So my vSphere data center name is VxRail data center, this one. Okay, VxRail data center. So that's included in the conf file. Okay, other than that, the URL for your vSphere. And since we are using a self-signed certificate, so the insecure flag is set to true. The user and the password, and the port is going to be 443, right? Now, once we have this file created, we will create a generic secret in our Kubernetes cluster, which will be used by the node drivers, right? So let me take this command, kubectl create generic secret, and the name of the secret is vSphere config secret from the file that we just created. And in the namespace, VMware system CSI. Okay, so let's create this particular secret. The secret is created. So what did we do till now? Created a cluster, exported the cluster ID, created a secret in a namespace, right, with these variables. And now we will go and deploy the YAML file for the CSI drivers. Now, before that, again, in the VMware documentation, it says that you need to go apply taints on your control plane nodes and things like that. Now, in our case, EKS Anywhere has already done that. So if we run this command, describe nodes taints, you can see that the control planes are already tainted actually, right? Okay. So that is also done. We don't need to do any of that. I've already mentioned that, the group label of group MD0 has been applied on my worker nodes. Now, where is the YAML file? There is a GitHub project for vSphere CSI driver. We can go to this particular project here. Okay. And the latest release as of now is release 3.4. We're going to select that release. Okay. And then go to manifest, vanilla. Now, this is a vanilla Kubernetes cluster. And then there is a vSphere CSI driver.yaml. We will take the raw URL of that. Okay. and I will download that particular file on my EKS Anywhere admin machine. Okay. Now, this is a default file. Some bit of customization required on that file, primarily for accommodating the node selector. Okay, so that the node driver pods are only created on my worker nodes. Now that the YAML file has been saved, the only edit that I will do here is to go and update the. Let's do that. I'm going to go and edit the daemon sets. Let's do that. The daemon sets are CSI, VMware. Is it vSphere CSI node? Let me just see. Okay, yeah, this is the daemon set. Let me just apply the node selector here. Okay, group MD0. Okay, and actually, I don't need the daemon set, which is the vSphere CSI node windows. So we can just leave it or let it be. I mean, anyway, the node selector is going to be Kubernetes IO OS Windows. So that's not there on our. So this pod will anyways not, this daemon set won't roll out, right? So we can just let it be as is in this YAML file. So the only change we have done is actually included the group MD0 as the daemon set required for this, right? So once we have this YAML file downloaded and edited, we will go ahead and apply this particular YAML, okay? So let's just look at the pods that are coming up in the namespace. VMware, VMware system CSI. Okay, so we can see that only the vSphere CSI node pods have come up because our nodes do not have the Windows label. Plus, there are only 2 pods running as a daemon set, which means 2 worker nodes. They are only running on the worker nodes as opposed to all the 5 nodes of the cluster, including cluster plane nodes. So we've got the whole CSI deployment done. In the blog, you can see I have also mentioned everything, all the steps. Plus, I've said that if you don't need it, you can delete it or you can leave it. It's your choice. We've left it as it is, the daemon set for Windows node driver. Let it be, it won't come up. And we applied this. Now we've already seen that the pods are running, the controller pods and the node driver pods, right? Now, what we will do is let's look at the current storage class. kubectl get SC. There should not be any default storage class. Like I said, prior to 0.16.0, there was a default storage class because the default implementation also included a CSI driver deployment of vSphere along with the storage class. Now, as of now, you can see that there's no storage class. We will go and create a storage class and make it is default class true, and the provisioner is CSI vSphere vmware.com. So let's copy this and apply here. Okay. And if we say kubectl get SC, you can see that there is a storage class that has come up here. Now, next is we will create a persistent volume claim. Now, this persistent volume claim, once created, can be mounted on any stateful application, and we will use it for a MySQL database. So I'm just kind of naming it as a MySQL PV claim. You can use it for whatever you want. The storage class name is vSphere-SC. It's the same name. If I don't provide one, it's okay because this is the default storage class. It'll anyways land upon that. But let's just, provide it. Okay, read write once is the access mode. I'm going to request for a 8 gig volume. Just make sure you have enough storage available on your data store. Okay, now importantly, if I go here and like I said, there are no container volumes as of now, right? This is cloud native storage, container volumes is blank. So once we create the persistent volume claim using this storage class and kubectl get PVC, we can see that the PVC has been created here and the volume is also created. And now let me just refresh this. There only. You can see that now in the container volumes, this volume shows up with the exact same name here, right? Which means to say that your persistent volume, which is deployed for a specific application, let's say, now has all the data being persisted as a container volume on the vSAN data store on the same VxRail cluster, right? So we've got the persistent volume up and running. Now let's see if we can mount this particular volume. We can describe all this. That's for you to do. We will create a MySQL service and a MySQL pod, and we will mount, the varlib MySQL path to the PVC that we just created. Okay, so let's do that. Okay, if the MySQL pod fails, which means it's not able to mount the volume. If it's in running, that means the volume is mounted. So you can see that we have successfully created a MySQL pod and that it's in running status. And obviously, if I describe this pod, it should say that, it's attached the volume actually, right, with this PVC. Now, anything that we actually write on this particular database or create a database and add in data, it's all going to be persisted on the PVC, which is now resident on the VxRail virtual SAN data store. So pretty much, that's a wrap. I hope, this is able to kind of, in a short and sweet manner, able to kind of, help you understand how do we deploy a persistent workload. You can do, which looks something like this visual, where you have the EKS Anywhere cluster with your control planes and worker nodes, and the VMs are persisted on a particular data store on a vSAN, and then your stateful pod, the one that we saw was the MySQL, is persisting itself. The data is persisted through the CSI drivers, which we implemented on the same data store, right? And seen as container volumes. I hope that this blog was useful. Thanks. Thank you. Cheers.